In this video, I'm going to talk about the different methods for operating reservoirs. And I'm getting this information from the U.S. Army Corps of Engineers Engineering Manual, or EM for short, 1110-2-3600, which is the Management of Water Control System. So if you want to read more about this topic, you can go search for this online. It's very easily accessible. So there are three different methods for operating reservoir. There's method A, method B, and method C. Probably the most important thing to understand is that each one of the methods is going to have trade-offs. So a method A reservoir, probably the easiest way to know that you are dealing with a method A reservoir is that it'll be looking downstream at a downstream regulating stage. Method A tends to be the most common method for operating reservoirs. The trade-off with a method A is that since you are using these downstream regulating stages to make the determination on what to release, you tend to provide benefits for the small and medium-sized floods. However, you do run the risk of completely filling your flood storage by providing benefits for the small and medium floods, so that when a large flood hits, you're out of flood storage and you're not able to provide as much attenuation as you would have been had you had more flood storage available. Now, the regulating stages, they can be constant throughout the year, or they can vary throughout the year. So in a lot of cases, in areas where you have agriculture, you have a lower regulating stage during the growing season and then a higher regulating stage once the growing season ends. And you can have a single regulating stage downstream, or the releases can be governed by multiple regulating stages. This is a very simple schematic that shows the zones in a reservoir. So this is showing the top of conservation. This is showing the top of flood. So the area in between these two is the pool that's used for storing flood waters. And so if you have something going on downstream for a long enough duration and you have enough inflow coming into the reservoir, it can completely fill this zone and get to the top of the flood, where a different operating criteria is going to come into play. So you won't be looking downstream as much. You'll be more concerned about protecting the safety of the dam at that point. That can be as simple as continuing to increase your releases systematically until you meet inflow. And what happens is you stop the rise of the pool, or your releases may be governed by a surcharge operation. Now, I have several videos that deal with surcharge operations. But the blue line here is showing the surcharge envelope curve. And basically, that's just a relationship between the pool elevation and the required discharge. And so you have your pool elevations on the y-axis and then your releases on the x-axis. And you can see, especially as you get to some of the higher elevations or the less frequent events or more severe events, that with each unit change in elevation, you're getting some big jumps in the release. Now, a lot of people think that when you get into this type of operation that you've actually made it worse than what would have happened had the dam not been in place, but that's not typically true. And one easy way to tell that is just simply look at the pool elevation as this is going on. If your pool elevation is rising, it means that you are storing a portion of the inflow, so your peak outflow is less than your peak inflow. And so you are providing a benefit. It's just that the benefit happens to be reduced. The next method is a method B reservoir. And method B is really it's almost the opposite of the method A. So instead of worrying about looking downstream, you tend to look at the pool. And instead of worrying about small and medium-sized events, you're really worried about the large events. You can see here that method B regulations involves making reservoir releases strictly according to the release schedule, the inflow design flood, so a very large event. It consists of releasing water at an established rate and then storing all excess inflow. And it does point out that it could result in higher releases for lesser floods, and you could reduce your benefits for these lesser floods. It does point out one example of a method B regulation being a dam designed with an ungated service spillway and a flood pool size to store the inflow design flood. But I do want to point out that you can actually have a regulated system that you could operate as a method B reservoir. And so I just did a very simple hydrograph to show the concept. So let's say that you have an empty flood pool and you start getting inflow into your reservoir. And the y-axis is inflow, and then your x-axis is time, and then the blue line is inflow, the red dashed line is the release. So if I'm empty at first, but I start getting inflow, then what I'm going to do is I'm just going to release all inflow up to a certain amount. And let's say that that amount that you came up with when you did your study was 1,000. So once inflow exceeds 1,000, I'm just going to hold my release at 1,000, and I'm just going to store anything that's above 1,000. Now, if it peaks out here and comes back down, I'll just hold 1,000 until I'm almost empty, and then I'll, start, decreasing my releases while also being able to empty the reservoir and take the flood pool to empty. Now, a method C reservoir is a combination of method A and method B. Basically, what you'll have is you'll have a lower zone in the flood pool where you operate that as a method A, and then you'll look to provide some benefit for the smaller floods. And then once you get to a certain elevation in the flood pool, then you'll switch over to method B, and you'll try to begin to provide some sort of protection for the larger floods, or for something like the inflow design flood. One thing, notice that we had said that you're providing protection for smaller floods, and then you're providing protection for really large floods, which means that, again, you have a trade-off, and your trade-off is going to be that you may not be providing as much benefit for like a moderate or medium-sized flood when you're dealing with a method C reservoir. Here you can see I just show just a very simple example on this schematic that we looked at earlier. I just added this blue line in the flood pool. So a method C would basically use this area and operate that according to method A principles, where you are looking downstream at downstream regulating stages. And then once you get above that line, then you would start operating that according to method B principles, where you're looking to be able to try to successfully handle something like the inflow design flood, or these larger events. So again, the most important thing to remember is that you have trade-offs with method A, method B, and method C. With method A, the risk that you run is that you could completely fill your flood pool and then get hit with a very large event. With method B, you're just not providing the benefits for the smaller or medium or moderate size floods. For method C, you're trying to do both of those. You're trying to provide benefit for the smaller floods and provide benefits for the very significant floods, but then you may not provide as much benefit for the moderate floods. So hopefully this helps you better understand the three different methods and the trade-offs with each method of reservoir operations. If you want to hear more of the videos that I make, feel free to subscribe to the channel, and thanks for watching this video.